Salam and welcome everyone. So today we're going to be working on the question on the screen that says write the wave function for a particle of mass 1.0 grams traveling to the right at 10 meter per second. Now the first thing I wanted to quickly mention is that we're told to write the wave function of a particle, and so basically we're supposed to determine what a particular wave function is of mass 1.0 grams. So we're given the mass to be 1.0 grams traveling to the right at 10 meter per second. So we've also been given the velocity. So we'll be given 10 meter per second. And basically they want us to determine the wave function. So this question is from chapter 7D of the Atkins Physical Chemistry 11th edition. And this topic for this particular session 7D is translational motion. And anytime you're giving a question like this, you have to first of all understand that when you're told that a particle travels to the right, that is telling you that it's only traveling in the right direction, basically. And there's a formula that we're going to need in a question like this. And the formula is called free motion in one dimension formula. And it states the wave function of x is equal to a e raised to the power of ikx plus b e raised to the power of negative ikx, where particle with linear momentum, positive k h slash, and then this is the particle, okay, with linear momentum, negative k h slash. Now you're going to be wondering, why did I write this? I'm writing this in order for us to know what's going on. We're told that this particle goes to the right. So if it goes to the right, this does not exist anymore. So we're only going to be focused on this one, because anything that goes to the right is going to have a positive value, and anytime the particle goes to the left, it's going to have a negative value. So this is the formula here. And we're told that the particle with linear momentum positive kh. So I'm going to rewrite that that the wave function of a particle going towards the right is going to simply be the wave function of x is equal to e raised to the power of ikx. We're going to ignore this value of a because it's not really something that we need in this question. But basically, this is what we are doing, is raised to the power of ikx. So we already know the x is a variable. We already know I is just the imaginary. So we have to solve for k. So K is also an unknown, basically. So yeah, write the wave function of a particle of mass 1.0 grams traveling to the right at 10 meter per second. So we've been given the value for mass, we've been given the value for velocity, and we also have K. Now, if you're really someone who is very, very if you pay attention to detail, you would know that they gave us the particle with linear momentum, positive k h slash, and you'd also notice that they gave us mass and velocity. So if you remember your physics very well and some part of general chemistry, you know that linear momentum, okay, linear momentum is just simply mass times velocity. And we're given mass, we're given velocity. But this question also tells us that the particle with linear momentum positive k h slash, which is just basically the particle going towards the right, is also positive kh slash. So we're just going to say positive kh slash is equal to mass times velocity because we're solving for k. So we know what the h slash is. It is a constant value. We were given the mass and we're given the velocity. Now, I want to quickly mention something. I've been saying h slash. Well, h slash is the same thing as the Planck's constant, okay, divided by another value. The value that I'm talking about is just basically 2 pi. So this h slash that I've been calling can also be known as the reduced Planck's constant. You see it in places where they can call it h bar, you can call it h slash, but I like to call it h slash. Basically, this is it. This is basically it's called the reduced Planck's constant, and it has the value 1.0546 times 10 raised to the power of negative 34 joules seconds. So basically, just to make sure everybody's on the same page, we have the value for mass, the value for velocity, and we're trying to solve for the value for k. We also have the value for the h slash, or the reduced plus Planck's constant. So the value for mass, rewriting that, we have that to be 1.0 grams, which I can just rewrite to 1.0 times 10 raised to the power of negative 3 kilograms. We have the value of velocity to be 10 meter per second. So yeah, we have all that we need here. So the formula, positive k h slash is equal to mv, and we can just simply substitute. So we have positive k multiplied by the h slash value, 1.0546 times 10 raised to the power of negative 34, okay, joules seconds. So joules seconds is equal to mass, which is just 1.0 times 10 raised to the power of negative 3 kilograms, multiplied by velocity, which is just 10 meter per second. Now, I want to quickly say something, and I'm sure a lot of you already know how I am on my channel. See, if you're given a question where the units don't match, we see we have seconds here, we have kilograms here, we have meters here, we have seconds, and then we have joules. Joules is not the SI unit for energy. The SI unit for energy is kilogram meter square per second square. So joules is also kilogram meter square per second square, and that's what we're going to substitute. For those of you who are confused, why did I get kilogram meter square per second square? If you remember from your elementary physics, they explained to you that joules, which is energy, is the unit, and it is from the understanding that the formula for energy is just force times distance, and then the formula for force is mass times acceleration. And yeah, that's it. So the unit for mass is going to be kilogram, the unit for acceleration is meter per second square, and the unit for um distance is just simply meter. So the joules can also be seen, or the SI unit for energy is simply kilogram meter squared per second square, aka joules can also be written as kilogram meter square per second square. So I'm going to use that knowledge and change and substitute joules for kilogram meter square per second square in order for us to be able to cancel out the units and properly do our work. So we have positive k is just simply multiplied by 1.0546 times 10 raised to the power of negative 34 kilogram meter squared per second squared. Okay, so that's just for joules. Let's not forget we have this unit of seconds here, so just multiply by seconds. Let's not forget, it's very, very important. So I multiply by seconds because this one is joules, and then this is the seconds that is left over. So anyways, that's why I'm putting that there. So is equal to 1.0 times 10 raised to the power of negative 3 kilograms times 10 meter per second. So yeah, that's it. So K is now going to equal 1.0 times 10 raised to the power of negative 3 kilogram multiplied by 10 meter per second divided by 1.0546 times 10 raised to the power of negative 34 kilogram meter squared per second squared multiplied by s. Of course, we can cancel out this one here, cancel out this one, cancel out the meters here. So from meter, cancel out that meter as well, cancel out the kilograms as well. And we also have one more seconds here. So we cancel that out and we cancel out this second. So what we have left for the unit of K is just 1 over m, or 1 over meters. So anyways, we go on to do the calculation. 1.0 times 10 raised to the power of negative 3 times 10 is just simply 10 times 10 raised to the power of negative 3 divided by 1.0546 times 10 raised to the power of negative 34. Okay, it's just going to be, so that's that divided by m. So when you input this information, 10 times 10 raised to the power of negative 3 divided by 1.0546 times 10 to the power of negative 34. When you input that information in the calculator, you end up getting 9.48227 times 10 raised to the power of 31 meter raised to the power of negative 1. So K is equal to 9.4823 times 10 raised to the power of 31 meter raised to the power of negative 1. And I want to quickly mention something to you. I wanted to quickly let you guys remember, or try to remind you guys, that anytime you're dealing with a science-based question, you should put your work in the proper number of significant figures. As you can see, our work contains raw values, and we have to put our final answer in the proper number of significant figures. So when we go back up, we see that the lowest number of sig figs is 2. So we have to estimate or approximate our value to 2 sig figs. So K is now approximately 9.5 times 10 raised to the power of 31 meter raised to the power of negative 1, or K is equal to 9.5 times 10 raised to the power of negative 31 divided by meter. So that's it. That's the answer for K. Our work is still not done. Remember what the question says. Write the wave function for a particle. So we have to write the wave function. So the wave function, just like I had explained earlier, I'll explain the wave function is just the wave function e raised to the power of I kx. We've determined what k is. So the wave function is just going to be e raised to the power of I multiplied by 9.5 times 10 raised to the power of negative 31 x. I'm going to ignore the units of k, which is 1 over meters, because I don't feel like that's necessary here. But if you want to write it, then you can write meter raised to the power of negative 1, or 9.5 times 10 to the power of negative 31 divided by, sorry, not negative 31. What am I doing? It's just 31. Gosh, this is how people mess up your work. When you did all this work only for me to like put in the wrong value. That's wrong. So the answer is 9.5 times 10 raised to the power of 31. So the wave function final answer would just simply be e raised to the power of I 9.5 times 10 raised to the power of 31x. So that is basically the wave function. And this is the answer to this question. If you have any questions, suggestions, or concerns, make sure you put in the comment section. I've done another video like this on my channel, although that one was set up a little bit different, but we're also supposed to write the wave function of a particular particle. So if you want a situation where you understand this particular question type as much as possible, make sure you watch that video. I'm going to link it in the description. If you're a student who is struggling in any of your STEM related courses, whether you're in middle school, high school, college, I am the tutor for you. I help students succeed in all their STEM related courses by my way of tutoring and mentorship. So if you're looking for a tutor or a mentor to help you through your academic journey, make sure you email me at shahabi@gmail.com. I look forward to helping you to the best of my capability. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.